All right. Really glad to be here and excited to share some of the things we've been working on for a while. My name is Martijn Walraven. I'm a tech lead at Apollo. And maybe we should just start by sort of reminding ourselves how lucky we are that we get to use GraphQL, that we get to write a query like this. Imagine you're writing a front end for an e-commerce site. You have a page where you want to show the top reviews for products. You want to show who wrote the review, and you want to include some information about the product, the name, the price, and you also want to know whether the product is currently in stock. This is what you need, and this is what you write. And this is all made possible by this amazing concept of having a data graph, a graph that describes all the data that's available to you as a developer, and then you write queries against this graph. One thing to keep in mind there is that as soon as you sort of break up this one graph into smaller graphs, as soon as you have multiple teams sort of coming up with their own GraphQL APIs, you're losing a large part of the benefit of that one graph. On the other hand, there are good reasons for actually wanting to break up your schema. Having one graph, making one graph available to your clients doesn't mean that you need to write one monolithic schema. So there are often really good reasons not to write your whole schema in one file or in one repository or in one NPM package. Especially if your graph starts growing, you'll be working together with multiple teams on this single graph. So you need to start thinking about ways to break up your schema while still exposing a single graph. And your initial inclination might be to just take the types of your schema and use those as your module boundaries. And this seems very natural. So this is part of that e-commerce schema that query ran against. We have a type user, we have a type product, we have a type review. These can live in separate files. Seems to make a lot of sense. There are some serious problems with this, however. If you look at these types, if you look at the fields in these types, they mix concerns. So type user, for instance, has a name. That seems to make sense. A username is something that's really fundamental to the base user type. But we also see a field reviews and a field recent purchases. These are not actually concerns of the user type itself. They are not concerns of your account's backend, for instance, that might be underlying the implementation of this type. Similarly, your type product may represent information living in your product database or a backend system managing the product in your store. It makes sense for that information to include the name and the price. But reviews seems like something that doesn't really belong there. One way of looking at this is in terms of feature development. So as teams start developing individual features on top of this one graph, extending the graph in the process, there's often a need to touch multiple types. And fortunately, GraphQL has a great built-in mechanism for this. And some of you may be familiar with this, especially if you've seen Peggy's talk from yesterday on client-side state. GraphQL has this notion of type extension. And that allows you to move these concerns to their proper place. So instead of breaking up your schema by types, you can now break up your schema by concerns. Your user type now just represents your account system. Your product type is part of your product system, but the extension on type user, a way of navigating from a user to your recent purchases, is just as much part of the product module of your schema as the product type itself. The reviews module is now a self-contained module that contains all the type information that's needed to implement this reviews feature. So you can have a separate team working on implementing reviews. Of course, they need a review type, but they also need extensions to other types. They need fields that allow client developers to navigate to these reviews, for instance, from users and products. So really, the main message here is that you want to break up your schema not by type, because that really mixes concerns, and it makes it hard to reap the benefits of modular development. If you really want individual teams to work productively together, you want to make sure that the module boundaries make sense. And I'm happy to announce that schema modularity is now part of Apollo Server 2.2. And let me show you what that means. If you're familiar with the current Apollo Server 2 API, you'll know that you construct an Apollo server by passing in type definitions and resolvers. What this allows you to do is, instead of passing in a list of type definitions and a list of resolvers, you can pass in a list of modules. And these modules are ordinary JavaScript modules. They can live within the same repository. They can come from an NPM package that you install in your project. And the basic structure should look very familiar to anyone who has attempted to break up their schema into modules. It's a JavaScript module that exports type definitions and resolvers. Looking at the type definition, of course, there's the review type. This is the module for the reviews feature. So there's the review type. Note that we're also extending type query, the query root, with a way of getting to the top reviews. And we're extending type user and type product here to give you those relationships that you can navigate to get from a user or a product to a review or a list of reviews. The implementation here may require a little bit of attention. One interesting feature of the schema modularity implementation in Apollo Server 2.2 is that schema modularity is not just about breaking up your type definitions. There are a few gotchas with composing type definitions, and some of those we take care of for you in Apollo Server 2.2. But the larger question for many people is, how do you actually break up your resolvers? Because if you think about it, a resolver in GraphQL, a resolver that returns an object or a list of objects, is mostly expected to return a more or less complete representation of the object. Because after you return from a resolver that represents a relationship, so for instance here, the author field or the product field, after that, the next stage in execution for GraphQL are the field resolvers. So after you return an author or a product, GraphQL execution would call the resolvers for the name and the price of your product, for instance. The problem with that is that it forces these author and product resolvers to fetch the data for those objects. And if you do that, you break modularity. You're forced to sort of pass around data loaders or data fetchers, some way of going from your review module into, for instance, your product database or your product backend service to fetch the data you need. Instead, what we've added in Apollo Server 2.2 is a way of returning a partial representation of an object. In many cases, the representation you return is just the primary key or other identifying information that the module that owns the type can use to fetch the data needed for that type. So in this case, we're not returning a full author, a full user object, but we're returning an object with just an ID. And then in the accounts module, we now have an extra hook on every object type. Resolve object. And an object resolver is similar to a field resolver, but where field resolvers are responsible for fetching data for an individual field, object resolvers run before the field resolvers for an object run. So they give you an opportunity to centralize data fetching for an object. And this is very useful in general, but it's extremely important for modularity. All right. So that's the first part. And I mean, this is something that I imagine will be very useful to people. It'll really help sort of grow modularity, modular construction of GraphQL servers. But once you start breaking up your schema into modules, you quickly land on a need to not just run individual code modules and compose those together into a single Apollo server, but a need to actually run those modules as separate services, separate microservices. And all the reasons for using microservices also apply to GraphQL microservices. So independent development, independent deployment, separation of failure conditions. So how do you actually go from modules to microservices? Well, you need a gateway. You don't want your clients to have to talk to these individual microservices. That gets you into the situation I described at the beginning, where you have 30 teams in your organization, and they all come up with their own GraphQL API with overlapping concerns, and you have to manually navigate between them. What you want is, from the perspective of a client, there should still be one graph. You want all the benefits of that one graph. You want to be able to run the exact same queries you run against a single Apollo server, but you want those queries to be automatically broken up into subqueries that get executed against your microservices. And this is something that, especially over the last year, a lot of people have started doing. I imagine some of you may be familiar with schema stitching and the implementation of that in GraphQL tools. That has generated an enormous amount of interest and enthusiasm. A lot of people have actually adopted this. They've started implementing gateways using it. But in talking to people who've done this, it becomes clear that there are a number of issues that are very common between these implementations. So how in this approach would you actually break up your schema into these microservices? Well, this is what we started out with. This was sort of our ideal module for the reviews feature. So we have the review type, we have our type extensions. How do you make this into a microservice? Well, what tends to happen is there's a need to split this up into two levels. The underlying microservice, the reviews microservice, has the base type, review, and the fields that it owns, the fields that it knows how to fetch data for, like body in this case. But there are other fields that represent relationships, or more generally, data that lives in other parts of your graph. In these existing schema stitching approaches, you're sort of forced to build out your microservice schema in a unnatural way from a GraphQL perspective. You're no longer really describing a graph. What you're doing here is describing a database model. You're exposing foreign keys. So instead of a relationship from a review to an author, I'm exposing an ID, similar for product. I also need entry points at the root level. So instead of navigating from a user to reviews, I now need a reviews for user root field and a reviews for product root field, which takes an ID. So that's obviously not the schema you want to expose to your clients. So you're forced to build an additional linking layer on top of this. And that is code that doesn't live in your microservice, but in your gateway. It's code that you have to write. So the team responsible for the reviews feature now is responsible not just for writing code that lives in their microservice, but they also have to write the linking code that lives at the gateway level. So the gateway level becomes a shared resource or a development bottleneck for your entire organization. That code, in many cases, also isn't trivial. So even the most simple implementation of schema delegation contains quite a bit of code. And this is code you have to write. In many cases, it's actually more or less write-only code. It becomes code that people really don't want to touch as long as it's working. But if things break down, that also means no one really knows how to fix it. So manually writing code to link together your schemas is dangerous. It's dangerous from a development perspective because it means the benefits of modular development. You lose the benefits of modular development at the gateway level. But it also has risks for deployment because this is user code that's running inside your gateway. And this is like your single entry point to your data graph for your entire organization. If one of your microservices or one of the teams developing one of those microservices pushes linking code to the gateway that is faulty, that somehow brings down that gateway, you have a huge problem. So there are two takeaways here. One is you really want to design your microservices not as sort of these isolated subschemas with foreign keys and root fields that are more like database queries than graph navigation. You also don't want to write user code. You don't want to write it because it's actual work to write it, but you also don't want to write it because you don't want user code running in your gateway. So schema composition, both for the local case and for the gateway case, should be driven by configuration, not user code. And what should that look like? This is the local schema modularity model that we discussed before. What if we just put this in a box and ran a gateway on top of it? That, to me, seems to be the ideal situation. So that's what we did. We built Apollo Gateway. It's part of our commercial platform. It runs on top of Apollo Server. And it allows you to declaratively compose these GraphQL microservices and then run queries against them. So let me show you what that looks like. Remember, before we were constructing an Apollo server and passing in a list of modules. Now, one of the ways you can do this is you can create an Apollo gateway and pass in a list of services. And these services are a combination of service definitions, information about the schema and related information, and a way to contact that service. Then, observe that we actually have a number of GraphQL microservices running here. So these are the exact same schema modules that we were composing in a single Apollo server before, but now we're running them as individual microservices. So we have accounts, reviews, product, and inventory. And I can run a gateway on top of it. First of all, that gives us an overall schema. There is no additional work needed to link together these microservices. The schema is created completely from these service definitions, which means that there's no sort of central linking layer. Every service is self-descriptive, and the overall gateway knows how to compose these services into this schema, which looks exactly the same as a schema you would create yourself, either as a monolithic schema or as a modular schema. So the distributed case is exactly similar to the local case. That also goes for the queries we can run, of course. So let's get the top reviews. A little bit of fake body text. Of course, that's not all we want to know. We also want information about the author. I happen to have written all of these reviews. And then there's the product. So products have a name. They have a price. There is a single product. So note that this is an actual schema. Validation works. I get all the tooling benefits that you've heard about at length during the rest of the conference, including the VS Code extension. And then the last service we are going to stitch together is the inventory service, because we want to know whether these products are actually in stock. And then let me show you what's going on underneath. So the gateway takes in a GraphQL query, has this internal representation of the composed schema and all the service definitions, and it generates a query plan. And a query plan is generated in advance before execution, which means it can be cached, it can be reasoned about, and it knows how to break up your queries and how to fetch these individual pieces that make up the overall query result. So in this case, top reviews, that's the first level. We're going to the reviews service. We're getting the body text for each review. And then authors and products are external objects. They don't live inside the reviews service. So instead, we get a reference. We then pass that reference for each author to the account service. And that allows us to get the author name. We also pass in the product reference in parallel, may I note, to the product service, giving us the name, the price, and something interesting, the product ID that we didn't actually ask for. So what's the reason for including this in the subquery that we execute against the product service? Well, we have one more query to make to the inventory service, and in order to know whether a product is in stock, we need the product ID. So the gateway knows that that's a field that needs to be added to the subquery, but it's also smart enough to filter that out of the result, because you didn't actually ask for it. So including it would generate an invalid response. So there are a lot of benefits to distributive execution. One benefit that I want to highlight is reliability. So we have 4 microservices running here. They all contain part of our data graph. Let's say one of them is down. So let's kill the inventory service. And let's re-execute this query. I get all my data, the exact same data, except for the inventory information. And this is an important property of GraphQL. This is a design feature of GraphQL. GraphQL has been explicitly designed to return partial results and a combination of data and errors. That's one of the reasons fields by default are nullable. You need to have a really good reason to make a field non-null. because the ability for fields to be null is extremely important for failure conditions. So here, if our UI has been designed to deal with the in-stock field, like the possibility of the in-stock field being null, which they would actually be forced to do if they use CodeGen, which would generate nullable types for these fields. They could display a list of top reviews that is still pretty useful to most users. And, well, I mean, if I were a user and I had to choose between not getting any data at all or missing one piece of data, I know what I would choose. Something else to highlight that I think is interesting is because these microservices all represent a proper part of the graph, unlike the situation where we had to expose foreign keys and root fields, we can actually do pretty interesting things. So for instance, if we ask not just for the top reviews, but also for other reviews from that same product that is listed as a top review, well, we get data. But looking at the query plan, what you see is that there's only a single query to the review service. There's no need to go to the product service in this case, because all information about sort of which products relate to which reviews is contained in the review service. So this is another important part of the reliability story. The schema design actually makes it possible to get this partial data, even relational data, in cases where one of the services is down, for instance. All right. So that's Palo Gateway. I'm really proud and excited that we're releasing this, and happy to talk to anyone about it. There's one more thing that I should mention. Apollo Gateway is not just a gateway on top of Apollo Server. It's built on Apollo Server. So if you're running Apollo Gateway, you're running Apollo Server, you get all the benefits of the new request pipeline. You'll be able to take advantage of features like caching. You get tracing. But that doesn't mean you're limited to running your gateway on top of Apollo Server. So there are teams that have decided to build their GraphQL server on Python or Ruby or Java, and those can all be perfectly reasonable choices. You just want to make sure that those GraphQL servers can still participate in that one graph that you're creating for your whole organization. And I don't actually have a Java server or a Python server or a Ruby server running. But one thing I happen to know is GitHub actually runs a Ruby server. So let me take out our account service and plug in the GitHub API and see what happens. Our gateway is reloading. It's fetching an introspection result from GitHub. And now, let me get some user information. That still works, conveniently, because I happen to have the same ID on GitHub as I have in this demo app. But what's amazing is that this actually brings in a complete GitHub user object. So I now have, wait, let me reload my schema. And now I have the ability to, for instance, get the company field that isn't part of the account service that I built, that is, of course, part of the GitHub user object. So this is not to say that everyone should be sort of stitching in GitHub user objects as their main authentication method in their graph. But it's a nice illustration of, without any work on the part of GitHub, we can actually make our gateway run on top of their server. based on a standard GraphQL introspection query, no further configuration data. The one thing, for those of you who are curious, we are using the node interface here as sort of a common mechanism across server implementations that we can utilize to automatically get an entry point into these servers. So that's Palo Gateway. It gives you the ability to expose a single graph to your organization, but it's built on top of this distributed execution layer. It composes the schemas of your microservices. It generates query plans that execute queries against those services. And everything else you've heard during this conference about sort of the amazing workflow that GraphQL enables, schema validation, the schema registry, the ability for clients to validate their operations against a schema, that all works on top of the gateway schema. One interesting use case there is the development of the microservices themselves. So as you're developing your microservices, because they are meant to be composed together with other microservices, you want to make sure that there are no conflicts, that you're actually always developing against the recent versions of all the other microservices, sort of keeping the overall schema in mind. So one way of doing this is to actually, as part of your CI/CD workflow, always build an overall schema from your current development version of the microservice you're working on, plus all the other services that make up your schema, create one overall schema, and apply all the same mechanisms that you can apply when you have a single server running against those. So validating things against real production traffic, for instance, to see what is actually breaking. I'm really happy to have been able to share this with you, and I'm looking forward to some stimulating conversations, and I'm happy to answer any questions you might have.